Hello, everyone. Have a nice day. So, anyway, this will be the next topic after the adjacency list. So, we'll begin to deal with regards to the next topic of our graph. So, the next topic that we will be going to discuss for today is all about the operations. So, the first operations that we will be going to deal with for today is all about the searching operation. So, pertaining to the searching operation, we do have here the two ways for the operations to perform for the searching. There are two different methods, which will be the breadth first traversal and the depth first search traversal. But in this video, I will only tackle first with the depth first search traversal before we go dive with the breadth first traversal. So let's take it slowly. Now, so let's define first what is all about the depth first traversal. When we say depth first traversal, that is a traversal algorithm that will visit all the vertices of a graph in the decreasing order of its depth. So that also will traverse a graph in depthward motion and uses a stack to remember to get the next vertex to start a search. When a dead end occurs, we'll apply the backtracking. So that means to say, class, that it's somewhat the same, similar in our tree that we are focusing to the depth of the depth in our tree. So say, for example, if you will be going to imagine here that this will be your graph right now, we'll convert that into a tree, for example. So let's try to imagine that this is a tree. So the A do have a children node of B as well as C. So next to B, there is an adjacent of D and E. And the next for that C don't have any child here in that situation. So if we are getting the depth first search traversal, we do have the in order, the pre-order, as well as the um what we call this one, post order in our tree. But here then in our graph, we will just focus what will be the depth in R3. So this will be our depth. So since that will be those do have a lot of child, or I mean do have a relationship to another vertices. So let's try to figure out how does it work later on. So here then, the first step for that one, suppose that your initial state is you are having there the node A. So that will be our first node to be traversed. So we'll begin to focus in that certain what they call this one, in that particular graph. So after that one, we will be going to we'll follow the algorithm here. So the algorithm that we have to follow will be this one. We will visit the adjacent and visited vertices, and then after downward, then mark that as visited already and push that in our stack. So in this depth first search traversal, we will be going to use the stack method. So if you can remember that stack, you can push element, then you can, if you will remove that is pop in element. So that is a last in first out method. So if no adjacent vertex is found in that particular vertex, so pop up a vertex from the stack in order for us to access the other node that still do have a relationship to another nodes. Then do the backtracking algorithm in the graph and search for another and unvisited adjacent vertices. I'm so sorry. So it's what I mentioned that we have to do the backtracking and do the backtracking as well as we'll continue on that for those unvisited vertex and repeat that 1 and 2 until stack is empty and all vertices has been visited. So this will be our goal here then. So let's try to do that one by one. Let's try to take it slowly. So in our next one, we'll begin to get the depth first search traversal for the undirected graph first. So for undirected graph here, for the depth first search traversal, this will suppose that A will be our initial state. So in that certain situation, we will be going to check where will be the next adjacent that do have a maximum depth, for example. So A do have one child, one connection, and A do have B, and B do have another sets here. So we can go here first in the B. So we push A first since that will be our first step already, since that is the initial vertex right now. Then after, we will push B since we'll mark this as visited right now. And after that, we already visited their A and we push B. So we will visit or we will check what will be the adjacent of B right now. So the adjacent of B, you can go to D or you can go to E. It's actually up to you since that won't matter actually. Now next here then, the third step you will we first traverse the letter D and we push that in our in your um stack, and please always make sure that you was also able to um update the top index or the top address here that from, if you can imagine here, I mean backtrack, let's try to figure out that from top 0, and when you push that is 0 to n address. Next, after the third step, the fourth step will also backtrack since D don't have any adjacent to itself, so therefore we cannot access E if we are now at vertex D. So we pop D here in the situation, and our top right now is equals to 1, and our depth for search traversal as right now is ABD already. Now, the next for that one, we are already here and in your B vertex. So what are we going to do? We will search another vertex which is connected to that. The next vertex which is connected into B is letter E. So we will push E right now in our stack. So that will become like that. And after pushing letter E in your stack, your top right now is already 2. After that one, you will also check if is there any adjacent to letter E. So your current duck for search is ABDE, and while checking here in your is there's no adjacent anymore. So that means to say we have to backtrack. So you can pop E in your stack. So E right now is being popped and your top right now is 1. And still the same thing, ABDE is the status of your duck first search. And since we are now at your B element or vertex, so is there any adjacent to B? So there's none. So means that means we have to do the backtrack. So we pop that in our stack. I'm sorry. And since we already pop that, our element right now will be A. So we are now at A. Is there any vertex or, I mean, connected nodes that we are unable to visit yet? So there is C. So we will now traverse C and we'll push that in our stack, and our stack status will be 1, and your depth for search traversal will become ABDEC. And after that one, you will check if there is adjacent to C. Since there's no adjacent to C, we can pop right now. And since we are already now at letter A or vertex A, we will also check if there is any adjacent as right now. So meaning wala naman. So we have to pop that, and in order for us that your depth first search traversal will be equals to your top, I mean, status will be -1. That is not one class, remember. That is -1 since empty stack signifies as -1. I'm sorry, I wasn't able to correct that. So that is -1, remember. Then, so that will be the, this will be our statuses right now, that will be the final depth first search traversal result for this particular undirected graph that will become A, B, D, E, C. So that's how you will do, you will do that here in the depth first search traversal. So that's the end of our video. I mean, no, that's not the end. I will also illustrate here for the depth first search traversal when in terms of directed graph. So before we'll end, I will also make sure to discuss this one. So for the depth first search traversal of the directed graph, you will also matter with the outgoing arrow. You can't traverse that element if, for example, letter A is having a something like that in order in going arrow. So A cannot go to D, something like that. That is actually restricted here. So the first step, suppose that you have A right now as your initial state. So we just push A in our stack, and we will also check what will be the adjacent of A. So the adjacent of A here, we can go to B. So we can push B right now. And after that one, we can also check if there is any adjacent to B. So there is D and E. So it's actually depend on you if where will you go. So for that one, we'll go to D or it could be E. That's fine. So I will push now letter D. And after pushing letter D, is there any adjacent to D? Yes, there is. So that points to E as well. So I can go ahead and push that in my stack. I can also push that supposedly. However, I do the backtrack here. I chose to go the to do the backtracking, but it's fine supposedly if I wasn't able to do the pop since I can push automatically E, but it's fine as well. So now you can we can go ahead and push E right now in our stack, and automatically we can also check here the status of E if there is any adjacent to E, so that there's no adjacent anymore. So we can also pop that in our depth first search traversal. So there's nothing to worry in going back here earlier for popping D, then go to B, since your depth first search traversal result will still print the same thing. Now, your stock current right now is letter E. So what are we going to do since we are stuck here, or we can't go back, go to another vertex since there is no adjacent. So we can pop that in your stack then. And after, I'm so sorry, we can pop that in your stack. So let me just say we have B right now. So we can check if there's any adjacent to B. Since there's nothing, we can go backtrack to the A. And if there's any adjacent to A, so we can also check here. So there is C that we're unable to visit. So we can push that in your stack. And after that one, check if there is adjacent to C, since the adjacent of C is D, and we are already able to visit that one, and just pop C in your stack and do backtrack, and we goes back to letter A. And is there any adjacent that we are unable to visit? So there's nothing. We just pop right now, and I forgot to update here in your depth first search traversal that your depth first search traversal is currently ABDEC already. So after you pop A, this will become empty and your top will become -1. So your final depth first search traversal row will be ABDEC. So be reminded that you must need to do the step-by-step process in your quizzes or in your examination as well. In that instance, that I could also know or able to see where or which path we're able to go then. So thank you so much. That's the end of our discussion for this particular traversal, and see you in the next video. I will begin to discuss all about the breadth first search traversal. So thank you.